All right, so we're getting ready for our Major Quiz 4 test, and we're going to do a review on that. We're talking about prime and composite numbers, and we're talking about prime factorization. So prime or composite, remember our prime numbers are the numbers that are only divisible by themselves. Composite divides by anything else besides 1 and itself. And remember that 1 is not a prime number because it only divides by itself. So let's look at 236. So for 236, is this going to be prime or composite? Well, I know it's an even number, so I know that it divides by 2. And I can find that 236 divided by 2 will get me 118. I can use division to find that, which tells me that 2 times 118 is 236. You can look at it either way, but that's showing why it is composite. So on this, you need to not just guess what it is, you need to show me why. When I look at the number 83, I can use my calculator and take 83. I can try and divide it by some of my prime numbers. If I divide, it won't divide by 2. Let's try 3. Doesn't work. 82. If it doesn't divide by 2, it won't divide by any even numbers. Oops, sorry. That should be 83. It won't divide by 5 because it won't divide by, it doesn't have a 5 or a 0 at the end. 6 is a multiple of 2. Let's try 7. All right, 83 divided by, can't be 8. Let's try 9. Whoops, forgot to hit our divide sign. 83 divided by 9. 83, well, it's not even, doesn't end in a 0, so it can't be 10. Let's go 83 divided by 11. 83 divided by 13. Won't be 15 because it doesn't end in a 5 or a 0. 83 divided by 17. 83 divided by 19. 83 divided by 21. 83 divided by 27. 83 divided by 29. I'm looking at all the odd ones because it can't be an even. 83 divided by 31. 83 divided by 33. 83 divided by, not 35. Let's try 37. 83 divided by 39. 83 divided by 41. 83 divided by 43. Now, if we get to 43, notice it's not even equal to 2. It has to be 2 of them, at least, to get there. Otherwise, you're not even half of it. So, this is going to be a prime number. So, just keep trying all kinds of numbers, and this will be prime, and then you got to tell me why. It's only divisible by 1 and itself. Because I've tried all the numbers, so nothing's going to work. So that's what you're looking to find on there. You only need to give one example. You can do any example that you choose, but you need to look at something like that. All right, so the next one we're going to look at is prime factorization. So this means we're going to factor it down to prime numbers. So if we start with 1890, I can see it ends in a 0, and we've also learned our divisibility rules. So if it ends in a 0, I know it's divisible by 10, and that's going to be 10 times 189. Now 10 is an easy one. I know it's 2 times 5. For 189, I don't know. It doesn't end in an even number, so I'm going to take 189, and I'm going to divide it by 3. I got 3 times 63. Now 63, I'm going to try that, divide it by 3, and I get 21. Now if you know it's 9 times 7, you can also do that. You'll get the same answer. So 21 is going to be 3 times 7. So now I have a 2, I have 3 3s, I have a 5, and I have a 7. That's what my prime factorization looks like. I need to write it with exponents. I have 1, 2, but I have 3 3s. So 3 cubed times 5 times 7. So don't be worried about how big the number is. Just keep working on them. All right, let's look at one more for prime factorization. If we have 55, 44, I know 4 is an even number, so I can divide it by 2 using my calculator. I get 2772. If I divide that by 2, I get 1386 because it keeps ending in an even number, so I can keep using 2. Divided by 2, I get 2 times 693. Well, 693 is not even, so let's try 3. And if I use my calculator, I find it's 3 times 231. It also divides by 3, and I get 77. Well, 77 I know is the same number, so it's going to be 11. So this will be 7 times 11. So now I've got 2 times 2 times 2 times 3 times 3 times 7 times 11. So that means I have 3 2's, so 2 to the third, 2 3's, so that'll be 3 squared times 7 times 11. Oops. So just count out how many you have. Make sure you don't leave any of your numbers off. So next we're going to talk about divisibility rules. So we've learned several divisibility rules. So we're going to look at 14328, and we're going to see what it is divisible by. And I'm just going to pick some numbers. So I'm going to see, is it divisible by 4? Now on this, you have to use their divisibility rules. So we know that from our divisibility rules that if it is divisible by 4, we can take the last 2 numbers and divide it by 4. It gets us to a whole number. So if I take 28 divided by 4, I get 7. Well, I got a whole number, so this one is a yes. You have to get a whole number, otherwise it does not work. So the next one I'm going to look at is it divisible by 5. Well, my divisibility rule tells me it ends in 0 or 5. This does not end in 0 or 5, so the answer is no. It does not work. If I'm looking by 8, by following my divisibility rules, I know it's the last 3 numbers divided by 8. And if I take 328 divided by 8, I get 41. That's a whole number, so it works, so the answer is yes. The last number we're going to do is by 12. So by 12, I need to do by 3, and I need to divide by 4 for it to divide by 12. That's the rule. So to do 3, that means I have to add up all my numbers. So 1 plus 4 plus 3 plus 2 plus 8. That gets me 18 divided by my 3, because that's the rule. You sum up all the numbers divided by 3. I get 6. That is a whole number, so that part works. Does the 4 work? Well, we already did the 4 up here, so we can just check that one off. You don't have to redo the work. So because it worked for both, the answer is yes. All right, let's go look at some more divisibility rules with a different number. So if we are given 5, 1, 6, 7, 8, I want to know if it's divisible by 2. So it has to end in an even number. Does it end in an even number? Why, yes, it does. It ends in 8. So that is a yes. I want to know by 3. Well, we've talked about that one in the last one. I have to add all of my digits up. I have to do the sum of them. And when I sum those up, I get 27. Does it divide by 3? Well, 27 divided by 3 will get me 9. That works, so it is a yes. By 6, I need to see if it divides by 2 and divides by 3. I've already worked both of those numbers out. It worked for 2, it worked for 3, so the answer is going to be yes because it worked for both. And then we're going to see if it divides by 10. Well, that tells me that it ends in 0. Does it end in 0? No, it does not. So that would be a no. The other divisibility rule that we can check on this one is it divisible by 9. So divisible by 9 tells us that we sum up the digits again, and this time we see if it divides by 9. We've already summed them, so you can just write your 27. If we hadn't done 3 already, we'd have to add them together. Divided by 9 gets us 3, and it works. It does not always work for both 3 and 9. Sometimes it only works for one of them, so that will be yes. So we've covered the divisibility rules for 2, 3, 4, 5, 6, 8, 9, and 10. So that's all you've got to know, and that's the work that I expect you to show on your exam. We have another type of problem that we're looking at, and that is finding our sequences. So for the sequences, we just need to plug in. So here we're looking at sequences. For this, we're looking at a sub n is equal to n squared plus 11. That's the sequence I'm giving you, and I want you to find the first 5 terms. So that means you're going to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So we're going to plug in 1 wherever n is. So this will be 1 squared plus 11, which is 1 squared is 1, plus 11 will get us 12. This will be 2 squared plus 11. 2 squared is 4, plus 11 will get us 15. 3 squared plus 11. 3 squared is 9, plus 11 will get us 20. 4 squared plus 11 will get us 16 plus 11, which is 27. 5 squared plus 11, 5 squared is 25, plus 11 will get us 36. So that's how you do that. Doesn't matter what the terms are, you're just going to plug it in. Doesn't matter what your sequence looks like. Let's look at another sequence of a sub n is equal to n plus 4 over 3n plus 1. And let's just, so we're still going to find those first 5 terms. So in this case, we're going to plug in our a sub 1. That'll be 1 plus 4 over 3 times 1 plus 1. 1 plus 4 is 5. And then we have 3 plus 1 gets us 5 over 4. A sub 2 would be 2 plus 4 over 3 times 2 plus 1. 2 plus 4 is 6. This would be 6 plus 1, which will get us 6 over 7. A sub 3 would be 3 plus 4 over 3 times 3 plus 1. 3 plus 4 is 7 over 9 plus 1, which will get us 7 over 10. A sub 4 would be 4 plus 4 over 3 times 4 plus 1. That'll be 8 over 12 plus 1, which is 8 over 13. And then a sub 5 would be 5 plus 4 over 3 times 5 plus 1. 5 plus 4 is 9. 3 times 5 is 15 plus 1 will get us 9 over 16. Now the other part you might need to do is find a given term. So if I give you a sub n is equal to 8 to the n squared minus 3, and you need to find the 32nd term. Your n is 32. You're not finding all of them, just the 32nd term. So a sub 32 is 8 times 32 squared minus 3. And you can put that in a calculator all at once and get 8,189. Now I might also give you something that looks like this. A sub n equals 2 times n plus 1 over 3n minus 2. And I want you to find the 36th term. So a sub 36 would be 2 times 36 plus 1 over 3 times 36 minus 2. So 2 times 36 would get you 72 plus 1. And 3 times 36 would get us 104. Nope, 108. 108 minus 2, which will get us 73 over 106. So that's all you need to do for exam 4, or major quiz 4.